So let's come on into the specialty lab. In this lab, we do various things, mostly focused on the energy market. So you'll notice that we have a lot of oil here. We do a lot of new and used oil analysis. And I'd like to introduce you to Corey. Corey Schomburg is one of our scientists here, and he's going to give a quick tour of this lab.
Hi, Jill. Welcome to the specialty lab. It's good to see you.
Nice to see you as well, Corey. Oh, and I see you've got the Oil Express running over here.
Yeah,
Can you talk a little bit about that?
We've got a lot of instruments running today. This is our Oil Express system. It's our high throughput FTIR system. We do lots of lubricant analysis with this system. So with this, we're looking at oxidation, nitration, and contamination, breakdown products, and that type of stuff with oils. It's a very valuable tool for assessing the condition of an oil and knowing when we need to replace it.
And why is that important? Why do we need to know we're changing oil? Obviously, this is for our cars. What analysis are we doing here for what kind of customers?
Yeah, so some of our customers use lots of oils in their systems. A turbine engine that does electric power might use several $1,000s worth of lubricant. It's important to know when that lubricant is breaking down and what condition it's in. We want to stop that failure before it happens. Lots of lights would be turned off if a turbine engine went down.
Right. Also, you don't want to change it too early, right? Because it costs so much money to change it. So it's all about the timing.
Yeah. Some of these turbines cost $5,000, $7,000 to replace the lubricant.
Okay.
And that may be a low estimate, because if something goes wrong, then it can cost a lot more than that.
Yeah, got it. So all these different systems in here do various types of analysis in this market, correct?
It is. We have our ICP over here, which does elemental analysis of the lubricants. Elemental analysis tells us when there are metal parts breaking down in the engines or in the turbines or whatever we're working on. It's a very valuable tool for assessing whether we're losing elements like phosphorus or something in the lubricant, or if we're gaining elements like iron or copper or nickel or something. It tells us what parts are breaking down. We also have this connected to our LPC 500, which does particle counting.
Oh, tell me a little bit more about that.
Particle counting combined with ICP allows us to do all of the analysis in one run. It takes about 45 seconds, whereas in a normal setting, this would be separate from the ICP, and both of them would take a lot more time to run than combined. So it saves labs an enormous amount of money and time by combining it into one solution.
Oh, very nice. And I see we also we do some various work with chromatography. And in this lab, we also have some hyphenation, correct?
Yeah. The hyphenation solution is one of the nice little things that PerkinElmer does. We do a lot of material characterization in the energy market, especially for like solar applications and things like that. So this is a really nice system. We put the sample in the STA there, and the evolved gases come over, and we can analyze them with the FTIR.
So the sample goes in here, heats up, the gases come through here, and then go into the IR.
Exactly. Gas phase analysis of whatever's in the STA is a very important analysis and gives us identification of what may be in the sample.
So it's a way of taking two separate instruments and combining them for additional information.
Exactly. Hyphenated systems give you more information than a single system on its own.
Perfect. Well, thank you for the tour, Corey.
Yeah, thanks for coming in.
So now we're going to come into our UVVIS near-infrared lab. And I'd like to introduce you to Aniket. He's another one of our scientists here at PerkinElmer. And we have various UVVIS, fluorescence, near-infrared systems. Aniket, could you give us just a quick overview of what this particular UVVIS instrument is?
Absolutely. So this is our dual beam UVVIS Lambda 365 instrument, which is generally used for measurement of liquid samples, absorbance, transmittance, all of those measurements. We have a number of accessories that comes with it, things like auto sampler, a sipper, a number of temperature control options, Peltier coolers that are used for controlling temperatures and modulating ramping in liquid cuvettes, for instance.
Okay.
And then
And then this is a little bit smaller instrument. What's the difference between this one and this one? This one is more of a diode array?
Right, so the Lambda 465 series is our photodiode array series, which is used for ultra-fast measurements of the entire spectra in one go. So whereas in Lambda 365, you have a monochromator-based system. Here, it's a single beam instrument, but it's photodiode array, so you're taking the measurement of the entire spectra very quickly.
Okay. And over here, we see fluorescence. And I know fluorescence is a lot more sensitive and lots of different applications. Where would we actually use fluorescence in the applied market space?
You know, a lot of applications, but something that jumps off now in the US especially is the blue-green algae. So if you want to characterize the fluorescence of those, some folks have used it to characterize the species of blue-green algae. So this is our FL6500 fluorescence instrument, shown here with a water jacket, a temperature holder, or a cuvette holder. In case you want to modulate the temperature while you're making measurements. It also has a number of different options to it. One of the things we have here is called an integrating sphere. So for instance, if you want to measure quantum yield of samples, we can use integrating spheres. Even for samples that have a lot of scattering, we can use integrating sphere.
Like
and
powders.
capture, like powders, for instance. Or,
so you can't put a powder necessarily in a cuvette and measure it, so you actually put it in a sphere.
You put it in a sphere, absolutely. Or turbid samples, for instance, all of those things can
Things
go in
that
a
are
sphere.
scattering a lot.
Things that are scattering a lot.
Okay, all right.
Absolutely.
And then I notice over here, we have a higher end UVVIS near infrared system, and there's various accessories. Can you give us just a quick overview of the instrument and what the various accessories are?
Absolutely. So this is our flagship product, the Lambda 1050 Plus high-end UVVIS NIR, shown here with a TAM system, which stands for a Total Absolute Measurement System. This is a kind of instrument that can measure from deep UV all the way up to near infrared. You have a sample stage, a detector, and these can all rotate with respect to each other. So there are a pair of concentric stages in here. You can rotate the sample, you can rotate the detector around
And what
it.
kind of samples would you actually put in here?
Architecture glasses, for instance, when you want to have an effect where sun is moving around, observers are moving around, we want to quantify that effect, measure that effect of how these things are.
So even like when I'm driving and there's the windshield, right? And the windshield at certain angles with the sun hitting it, is that an application you would use this for?
Absolutely. So there are a number of coating materials that go on top of the windshield, and all of those things could be characterized here. What is the effect of angular effect? How's the transmission? What is the reflectance? Things of that nature.
Okay.
And then we have a number of accessories here. This is the more important one, the 150 millimeter integrating sphere. So this is used for measuring the scattering of various samples really at normal angle of incidence. So you have a transmission port, at the back is a reflection port. We can do all normal angle transmittance, reflectance measurement, haze measurements, color measurements, etc. on the integrating sphere.
So again, it's a sphere similar to a sphere, right? So solid samples. What kind of applications would you use this sphere? Now I remember a customer that was looking at a particular spot on a product, and they wanted to like hone in on that spot. Would you use this accessory?
Absolutely.
For that?
So we have this little thing here, which is called a small spot accessory, that can be used to focus beam on a very, very, very small spot, either on the transmission side or reflectance side. So if you have a non-homogeneous sample and we want to measure little spots on there, we can use the small spot accessory and measure all of those things.
And also, some customers use spheres for all different kinds of applications.
Mm-hmm.
But if they have a UVVIS near-infrared system, they could also use the sphere for color, could they not?
Absolutely. So these are what is called as an absolute measurement system as opposed to a relative measurement system.
Right.
So anytime you're measuring on a 150 millimeter sphere, as long as you measure in the same instrument at any lab in any part of the world, you're always getting the same numbers. And those are the numbers, you take the transmission, the reflectance data, convert it to LAB values, measure colors.
Right.
And
And
get the
so
same
that's
number.
really important in color. It's also really important like with solar, right? You need an absolute measurement. Now you can do a relative measurement by using a different sphere, but then you have to do some calculations. So you could use this also for solar. I know there's a lot of research being done on solar, correct?
Absolutely, yeah. We can use it for solar, reflectance transmittance measurements, TSR, total solar reflectance, is a very common measurement that is done here. We can also use the sphere in different formats to look at first surface reflection, second surface reflection from various materials. Very common application that we see now with this in the solar or the semiconductor field is band gap measurements in powder materials.
Okay.
And we can measure diffuse reflection from the sphere and make calculations and do those measurements there.
Okay. Anything else you want to touch on? I know this is an accessory.
Yeah, there are a lot of
top off.
accessories here, but we'll look at this accessory. This is called a URA, or universal reflectance accessory, which is used for measurement of specular samples. So if we just think of very, very polished samples, mirrors for instance, where there's not a lot of scattering, you don't have textured surface, but very smooth surface.
And you just lay it on the top there.
This is the beauty of URA. You just lay the sample on top, cover it up, and you're good to go. Again, this can also make angular measurements, much like how the TAMS can do, but there are more nuances to it, only in the positive angle and only specular reflection
And
kind of
these just
measurements.
pop in and pop out, right? You just pop one accessory in, use the other one. Turn
Absolutely.
off the instrument, obviously. And then put the next one in.
So no hot swapping, right? No hot swapping. But the 1050 platform itself is modular, which means you get the bench, and then any of the accessories you need, you can take off the TAMS, put the sphere, take off the sphere, put the URA. There are a number of different accessory options that we have, including some very big spheres that can all go in and out of the same basic 1050 bench.
Perfect.
All right,
All
thank
right.
you.
Thank you so much,
Thank
Aniket.
you. All right.
Okay, next we're actually in the thermal analysis lab, where we have various thermal analysis instruments, including our carbon, hydrogen, nitrogen, sulfur instruments, TMA, DMA, some DSCs, TGAs, and hyphenation. I'd like to introduce you to JP. Hi, JP.
Hi, how are you?
Can you talk to me a little bit about the CHN, some of the applications that we actually use it for? I know it's a frontal chromatography system where you put samples in there. I know soil is a big one, right?
Yeah, soil, agriculture products, polymers, pharmaceutical products.
Okay, and also in the applied markets, soils is very big, cosmetics, the coal, things coming off the stacks, and
Energy,
coal
yeah.
is analyzed, and you put it in the tube, and you just basically heat it up, put your sample in there, it drops in there, heats up,
Yeah.
and it's frontal chromatography.
Yeah, the CHN-SO includes 3 different parts. And first one is the pyrolysis or the combustion. The second one is the GC or gas separation part. The third part is the detection. This
And-
one, all 3, in one and very self-contained system.
Yeah, and so the pyrolysis part, the burning up, is very important. And on this particular instrument, you can actually add time, because if you don't burn the sample totally up, the analysis isn't going to give you very good data, correct?
Yeah, absolutely, yeah.
Okay, let's go over here and take a look at some of these other systems. We've got our DMA, dynamic mechanical analyzer, and our TMA for coefficient of thermal expansion. Can you just talk a little bit about these 2 instruments and how in the applied markets they might be used?
Yeah, the DMA is a dynamic and mechanical analyzer. It measures the rheological or viscoelastic properties. And we have 6 modes to put to the test. And also we can measure the damping, compliance, and several different thermal properties.
So various components go in here,
Yeah.
and you clamp them different ways.
Right.
And I don't know if we have a diagram, but you can put them in, so you pull them, push on it,
on.
Various types of things. Maybe an example of this, and I know one of our customers, they're looking at some of their plastics that they have on their product, and they actually put it in here, and they measure it to make sure that it can withstand certain things, correct?
Yeah, correct. And also you apply the frequency of the load or force, and it's a function of the frequency, temperature, or shear. So several different modes we can choose from.
Okay. And this is, a lot of people know TMA is mainly used for the coefficient of thermal expansion, a very simple application, correct?
Yeah, that's absolutely. And TMA is thermomechanical analyzer. It measures the dimensional change as a function of temperature, load, or time, or combination of all 3 parameters.
Okay. And then, and I know we have a couple of different types of differential scanning calorimeters, or DSC. We've got a single furnace and dual furnace. Can you just give me just a couple minutes on the two different systems and maybe some of the applications there?
Yes. The single furnace is we call the heat flux technology, and the dual furnace, that's we call the power compensation technology. And the single furnace is very conventional. It's suitable for most of the QA/QC or basic research needs. And our dual furnace power compensation DSC is suitable for not only the basic research need or QA/QC, also more advanced research approaches.
Okay, so if you look at this, and I used to carry one around with me, the two furnaces, the benefit of actually having this particular instrument is that they're so small, everything heats up fast, right? Like a car engine heats up, but the cool down is the key in a lot of thermal analysis samples, when you're running samples by thermal analysis. So the smaller furnaces can heat up very quickly, but the key is they can also cool down very quickly. Is that correct?
Absolutely. This dual furnace technology can heat it up, cool down up to the 750 degrees C per minute. And compared to the single furnace, about the 200 degrees C per minute, that's about almost like 3 times more faster.
Yeah.
And also allow you to detect a very, very weak transition or very weak thermal properties.
So the sensitivity is actually improved
Yes.
also because of the smaller furnaces and the speed. Plus you can emulate some processes that maybe they have a quick cool down and maybe in your process.
Yeah, absolutely.
Okay. And then this is again, we were in the specialty lab with Corey, and we saw that we had, 2 instruments connected, and we call that hyphenation, where we take 2 instruments or 3 instruments and we combine them to get more out of those instruments. So here I see we've got a TGA and an IR and a GC with a mass spec. Can you just touch on a little bit about this particular configuration?
Yeah, absolutely. TGA is a thermogravimetric analyzer. It can measure the mass change of a sample as a function of time, temperature, or both. And the ultra-sensitive, the balancer can give you the very precise measurement in real time, and also then the ultra-sensitive, they can go down to the 0.1 microgram. So it's very, very sensitive. It can detect
so it's got its own built-in balance in there.
Yeah,
so it weighs the sample, heats it up, and then what the gas is coming off, you can measure it. You can see the measurement on the screen there, but you can also hook this up to go into the IR and get additional information out of the IR, and then also send it over to a GC mass spec to get even more information out of it, correct?
Yeah, that's right. And it can measure the gas composition or different chemicals from the gas coming from the TGA.
One of the applications I like to think about for thermal analysis is a plastic bottle. When you drop a plastic bottle, it bounces on the ground. But if it were manufactured incorrectly, it could actually drop and shatter. Can you give us what that's regarding, like how does that happen?
Yeah, it's related to the crystallinity. The crystallinity actually affected the flexibility. So the TG, or we call it TG, and the higher the TG, actually the higher the crystallinity.
Okay,
Yeah.
so the TG is the glass transition, and if you have that incorrect, a normal plastic bottle, when you manufacture it and it drops on the ground, it'll bounce. But if you have the wrong transition, the wrong crystallinity, you could drop it and it could shatter on the ground.
Yeah, absolutely.
It's an interesting application, right?
Yeah, very interesting. Thank you.
Okay, thank you very much, JP.
Thank you, Jill.